What would happen if we went faster than light? Today's video may be a little hard to understand, but if you know all of them, you've beaten 90% people in the world. Next, we're going to take a ride in a spaceship and experience the magic of faster-than-light travel. And in the process, not only will we see strange sights, but we'll also get to the heart of special and general relativity. We launch a spacecraft on Earth that has unlimited fuel, and the spacecraft can maintain a stable acceleration similar to Earth's gravity. So when you're flying through space, even if you're speeding up to nearly the speed of light, it's exactly like living on Earth. When we travel through space at high speeds, the first thing we see is all the stars shrinking in front of us. This is actually an optical aberration. What is that? For example, when you are driving, you will notice that the raindrops will fall towards your car at an angle instead of vertically. The same goes for light. Light that is perpendicular to you will also change its angle as you move, so you will see it shrink and brighten in front of you, which will also cause the view in front of you to become distorted. But that's just an optical illusion. As you look behind you, the sky will diverge and darken behind you. Besides optical aberration, there is another optical phenomenon. If you look at people on Earth through a telescope in a spaceship, you will notice that they are moving slower and it's going to redshift. If you were to look ahead, the starlight would blue shift. This is known as the Doppler effect. But as the spacecraft travels faster and faster, approaching the speed of light, irreversible physical effects will occur. The first is the time dilation effect of special relativity. We know that the universe is a four-dimensional space-time structure, when the spacecraft has not yet taken off. It and the Earth together at the same speed in the timeline into the future. But as the spacecraft moves through space at higher and higher speeds, it no longer follows the same path through time as the Earth. If the spaceship returned to the Earth, because the spaceship and the Earth, this space-time trajectory is not the same, so the people on the spaceship experience time and Earth people will be completely different. The people on board will be younger, and that's the time dilation effect of special relativity. Another consequence of special relativity is length contraction. As the spacecraft approaches the speed of light, you can see that space is shrinking in the direction of motion, which is no longer an optical illusion. This means that the distance between you and your destination will be shorter. The immediate consequence of that is that as you get closer and closer to the speed of light, it takes you less and less time to get anywhere. You can even travel thousands of light years in seconds. If you could travel at the speed of light, you would go anywhere in a flash. Because reaching the speed of light means time not running. But be warned, this is happening from your point of view. Then a long time, to you, is a moment. But for Earth, it could have been thousands, tens of thousands, or even billions of years. But special relativity limits us to reaching or even exceeding the speed of light. It doesn't matter how fast you're going, even if you're very close to the speed of light. Light is always escaping from you at the speed of light, so nothing can travel through space faster than light. There is a way to get around this rule. Special relativity restricts matter from traveling faster than light in space, but it does not limit space itself from traveling faster than light. And that's the warp drive, which we talked about in a previous video. If you're interested, check it out. If one day we build a warp drive, reaching or even exceeding the speed of light, incredible things will happen. Because light can't travel as fast as the spaceship now, the spaceship has actually flown away. But his light has not yet reached our eyes. All we can see is the trace of the ship. And when the ship reaches the speed of light, everything in front of it will shrink to a point, and that point will look very bright. And behind you will be endless darkness. If you find the video helpful, please follow my TikTok.